All right, number 5, we're asked to sketch the relation described by this. So we have points x comma y, x squared is less than or equal to y, which in turn is less than x plus 6. All right, so the strategy here is let's graph y equals x squared. We know what that looks like. That's a parabola. We haven't moved it around at all. That means we have the vertex at 0, 0. And to get a good graph, we can plot a couple of points. 1, 1, negative 1, 1, two, 4, negative 2, 4. Oops, missed it there. That's good, I'm going to get it. So that's y equals x squared. So if I want y greater than or equal to x squared, I'd be wanting points whose y value is greater than the corresponding x squared value. In other words, I'd be looking for points that are above the parabola. Now I'm going to graph y equals x plus 6. Well, that's a line. It's got a y-intercept of 0, 6 and a slope of 1. So I can go ahead and instead of drawing a solid line for this, since it's a strict inequality, I'm going to draw a dotted line. So if I want the y's that are less than this, if I want the points whose y coordinates are less than that, I want everything below this dotted line. So the region that I want is going to be the points that are above the parabola, but at the same time below the dotted line, which is going to give me all these guys in here. Now, what about where the line would cross the parabola? Well, those would be points on the line y equals x plus 6. I'm not allowed to have those, so what I need to do is open those up as circles. So I'm going to have an open circle there, an open circle here, and then I can erase everything else. And that would be the region I'm talking about. Well, what are the coordinates of these holes? That might be something good to know. How could I figure that out? Well, I'd be looking for where these two graphs intersect. And how do I find where the graphs intersect? I'm going to set these equal to each other. Subtract this off, factor, and solve. So this tells me that the x-coordinate of the intersection point is negative 2, and the other coordinate is 3. So that gives us the x-coordinates of the intersection. What about the y-coordinates? Well, to get the y-coordinates, I take the x value and plug it in. It shouldn't matter which of these I plug it into. I should get the same y value out. When x equals negative 2, if I plug negative 2 into here, I get 4. If I plug negative 2 into here, I get 4, which is what I should because that's where the graphs intersect. And when I plug in x equals 3, I plug it in here, I get 9. I plug it in there, I get 9. So this is a detailed graph of this relation. That'll do it for number 5, and that'll do it for checkpoint quiz 2.4.